Hey folks, section 5.6, we're going to look at a topic that you may be familiar with from an econ class. It's called elasticity of demand. In this section, the objectives we're going to look at is objective 1. We're going to determine what's called an arc elasticity. Then objective 2, we're going to determine a demand function given the price demand function. Then objective 3, we're going to determine an elasticity of demand, which is also called point elasticity. And this may be what you've seen in a prior econ class. Then in objective 4, we're going to interpret what elasticity of demand tells us. And then objective 5, we're going to determine a price adjustment. So to get us started here, if there are small changes in the unit price of a product, and that results in significant changes in demand, the product is said to be elastic. However, if small changes in the unit price of a product do not result in significant changes in demand, that product is said to be inelastic. Now, typically, there are day-to-day items such as gasoline, which most everyone uses, that would be considered inelastic, while big ticket items like washers and dryers, they would be considered elastic. So when actual changes in price and quantity are known, so we actually know them, and a price demand function may not be given, an arc elasticity is used. So arc elasticity, it's for finite changes in quantity and price. Arc elasticity, which I'm going to denote as this uppercase E sub A, it's kind of sort of like an average rate of change in an odd way. But here's the definition for arc elasticity. Notice it's the opposite of the change in Q over Q, all that divided by the change in P over P. Or in other words, it's the opposite of Q2 minus Q1 over Q1. And then all of that over P sub 2 minus P sub 1 over P sub 1. And here Q1 and Q2 are the original and new quantities, respectively. P1 and P2 are the original and new prices, respectively. So let's look at a quick example dealing with arc elasticity. CJ Studio, they offer a glass blowing lesson. Their normal price of $100 per class, and that's 86 participants a week. Now, by offering an online coupon which reduced the price to $80, there were 112 participants a week. So let's determine the arc elasticity. So please write this down because I'm heading to the chalkboard. All right, folks, this example was an example of arc elasticity. I didn't write all the words down, just some of the really important stuff. That the normal price of $100 nets 86 participants in a week. If they reduce the price to $80, it nets 112 participants in a week. So the normal price, the original price is $100. That means this is P sub 1. And the 86 participants, that's the original quantity, that's Q sub 1. 80 would be the P sub 2, and 112, that'd be the Q sub 2. So here's the formula for arc elasticity. It's the opposite of Q sub 2 minus Q sub 1 over Q sub 1. All of that over P sub 2 minus P sub 1 over P sub 1. So just substituting in the numbers. So we have 112, that's Q sub 2, minus 86, Q sub 1, over Q sub 1, which is 86. And that's all over P sub 2, which is 80, minus P sub 1, which is 100, all over P sub 1, which is 80. So if we clean this up just a little bit, let's see, that gives us a negative, or the opposite of, see, that's 26 over 86. And this gives us a negative 20 over 80. And then if I just use a calculator to get a decimal approximation, we get we get positive 1.512. So the arc elasticity was 1.512. So we're going to head back to the slides, and we're going to see that, since that number is greater than 1, we say the demand is elastic. So let's head back to the slides because, we're going to talk more about elasticity. How do we know if it's inelastic or elastic or something called unitary? And then the more important topic here isn't arc elasticity, it's called point elasticity, which is going to involve the derivative. So let's head back to the slides. All right, so we just worked through an example dealing with arc elasticity. It has to be mentioned that arc elasticity will not provide the elasticity for a single quantity demanded. In that case, we need the instantaneous change in price and quantity, and that gives rise to what is called point elasticity. So you can bet there's going to be some calculus involved here because we see the word instantaneous italicized. Now recall that the price demand function P, it gives the price P of X at which people buy exactly X units of a product. If we solve the price demand function for X, we get simply the demand function. Now the demand function, which will be denoted D of P, it's simply X equals D of P. And it gives the quantity X of a product demanded at price P. So we have to have the demand function in order to determine point elasticity, or the elasticity of demand. So to determine the demand function, we're going to have to solve for X in the price demand function. So this is an important skill that we need going forward. So let's look at a quick example in practicing this skill. So in this example, we're going to determine the demand function, X equals D of P, for the price demand function, P equals 500 over square root X, where 40 is less than or equal to X is less than or equal to 100. So please write this down. It's an important skill for the bigger picture here in section 5.6. And I'm going to head off to the chalkboard and work through this. All right, folks, in this example, we were asked to find the demand function, X equals D of P, for the price demand function, P equals 500 over the square root of X. So what we have to do is take our P equals 500 over the square root X, and we have to solve that for X. So we get the just the demand function. And this is an important skill, going forward in the rest of the section. So to solve this for X, I would start off by just multiplying both sides of the equation by square root X. Then divide both sides of the equation by P. Then square both sides. So that gives me X equals 500 over P quantity squared, which 500 squared is 25,000. And then, P squared is P squared. So the demand function, X equals D of P, it's 25,000 over P squared. Okay, I'd like you to practice this real quick. So here's one to try. Go to the section 5.6 exercises. Try number 16. And you know the drill. After you do number 16, pause the video, do number 16, then restart the video, and I'll be here at the board working through it. All right, folks, in number 16, you were given the price demand function, P equals 700 over 2x plus 1, and you were asked to determine the demand function, x equals d of p. So that means we need to solve this equation for x. My first step, multiply both sides of the equation by 2x plus 1. Next, I'll go ahead and just distribute the p, so I have a 2xp plus p equals 700. Then I'll subtract p from both sides. And then my next step is to divide both sides of the equation by 2p. So I divide the left side by 2p, I divide the right side by 2p, and I get x equals 700 minus p over 2p. So we have determined that the demand function is 700 minus p over 2p. All right, now we have everything in place that we can officially, we're going to head back and we're going to now define and talk about point elasticity of demand. So let's head back to the slides. All right, now that we've sufficiently practiced the skill in determining just the demand function, x equals d of p, and I asked you to also do a homework problem to practice that, let's continue on. So in order to determine the elasticity for a single unit, instantaneous change in price and quantity is needed. What that means is we would need to study how demand would increase from d of p to d of p plus h, while price changes from p to p plus h. This is sounding an awful lot like, leading into something with the derivative. And if we take the limit as h approaches 0, that allows us to derive the formula for elasticity of demand. You can read that in your book. So here we go. This is the definition for elasticity of demand. If you have demand function x equals d of p, the elasticity of demand, which is denoted by E of p, of a product at current price p is given by, well, there it is. E of p equals the opposite of p times d prime of p all over d of p. So no surprise, we see some calculus involved here. We need to know that elasticity of demand. So why don't we practice here? Write this example down. We're going to determine the elasticity of demand, E of p, for the following price demand functions. So part A, P equals 15 minus 0.75x, and in part B, P equals 256 over 4 minus x. So, get this written down. I'm going to head off to the chalkboard, work through them, and notice in both parts, A and B, we're going to have to begin these problems by first solving for x. So we have x equals d of p. That's the skill that we had just looked at in the prior example, and I believe it was exercise 16 I had you to work on. But in any event, let's head off to the chalkboard and see what we can come up with. Hey folks, in this example we were asked to determine the elasticity of demand, E of p, for each price demand function. So in part A, we're given the price demand function of p equals 15 minus 0.75x. So the first thing we have to do, and I just mentioned it before we headed off to the chalkboard, is in both of these we need to turn it into just a demand function. We need to turn it into x equals d of p. So we have a little bit of work to do first before we can find the elasticity of demand. So remember, I have to solve this for x. I would make my first step subtracting 15 from both sides. And I'm actually going to rewrite this decimal as a fraction. Now I multiply both sides of this equation by -4/3. And, while I'm here, I'm going to go ahead and distribute the -4/3 to get a -4/3 p. Let's see, that's plus 20. That's what x is equal to. And remember, x is d of p. So we had to do this first because now when we apply and we use the elasticity of demand formula here, which, let me write that down. It's E of P equals the opposite of P times D prime of P all over D of P. Well, we can quickly get this as -P times, all right, so here's D of P. The derivative. The derivative, D prime of P, is just -4/3. So this is -4/3. And then that's over D of P, which is -4/3 P plus 20. And I would probably say we could at least write that, we can multiply this together to get a positive 4/3 P over -4/3 P plus 20. And you know what? If I multiply the numerator and denominator by 3, I get something that looks a little more user-friendly. 4P over -4P plus 60. So that's E of P, the elasticity of demand, for part A. For part B, well, we have to start off by solving that for x. We have to see it as a D of P. So first step, I would multiply both sides by 4 minus x. Then I'll distribute the P, so I get a 4P minus PX equals 256. Subtract 4P from both sides. So I have a -PX equals 256 minus 4P. And then I divide both sides by -P. And I'm going to rewrite that. Instead of seeing 256 minus 4P over -P, I'm going to rewrite it as two separate fractions. Because, that gives me, 256 over -P. I can write that as -256 over P. And then when I take a -4P and divide it by P, I'm just left with a plus 4. That's my D of P. So when I use my elasticity of demand, E of P equals -P over D prime of P over D of P, I get E of P equals -P times, all right, so I have to get the derivative. I have to get the derivative of this function. Keep in mind that's D of P. I'm going to rewrite this to make the calculus a lot easier. Remember, I can rewrite -256 over P. I can write that as -256 P to the -1st plus 4. And getting the derivative, boy, it's a lot easier now to get the derivative, because the derivative is, okay, so I bring the -1 out front, that would be 256 P to the -2nd. And then that's all over my D of P, -256 P plus 4. Now if I clean this up just a little, and I do want to clean this up just a little, so if I clean it up just a little, I get, rewrite that as 256 over P squared. So I have a negative p times 256 over p squared. And this is all over negative 256 over p plus 4. Then I see that p will cancel out with one of those p's. So I have a negative 256 over p all over negative 256 over p plus 4. And you know, if I multiply the numerator and denominator, if I multiply the numerator and the denominator by p, I get negative 256 over negative 256 plus a 4p. That's all there is to it. So let's head back to the slides and see what we're going to do with this. All right. We've now practiced finding the elasticity of demand. And look, keep in mind it's a function. It's a function of P, price. Let's look at this. Nice table here that summarizes some stuff. So if for a value of P, so when we know P, when we do E of P, that is, we compute the elasticity of demand. If the E of P value is between 0 and 1, then the demand is said to be inelastic. And that means a change in price will cause a relatively small change in demand. Now, if the E of P value is greater than 1, then we say the demand is elastic. And that means that a change in price will cause relatively large changes in demand. Now, if we happen to find that the E of P is equal to 1, then we say the demand is unitary. And that means a change in price will cause a relatively equal change in demand. And there's going to be, later on, we're going to see there's something neat about when E of P is equal to 1. But now let's look at this example. It's going to be a lot of words for you to write and get into your notes. You got a demand function for a self-published book is modeled by that function. It's kind of nice. It's already in the D of P form. P is the price per book, and D of P gives us the number of books sold. We are going to find and interpret the elasticity of demand when the price is $8 and when the price is $12.50. So we're going to head off to the chalkboard now and work through this and get this written down, because here I go to the chalkboard. All right, we were given the demand function for a self-published book. That was the demand function. D of P equals 600 minus 2P squared. P was the price, and D of P is the number of books sold. We were supposed to find and interpret the elasticity of demand when the price is $8 and then when the price is $12.50. So remember, let me write it down one more time. Elasticity of demand is equal to negative P times D prime of P all over D of P. Here, let's see, D prime of P is a negative 4P. So let's do let's get our elasticity of demand in general. So in general, it's E of P is negative P times a negative 4P all over 600 minus a 2P squared, which, let's see, simplify just a little bit. That's 4P squared over 600 minus 2P squared. So let's see what's happening when the price of the book is $8. We have E of 8 is equal to 4 times an 8 squared over 600 minus 2 times 8 squared. Just tossing 8 in here for the p's. And I end up getting, as a decimal, going to round it off, 0.4 0.5424. That's enough decimal places. So notice E of 8, it's a number between 0 and 1. 0.5424 is between 0 and 1. That means at a cost of $8, it's inelastic. Now, inelastic means that if we make a small change in price, so we're making if we make a small change in price, that small change in price, it would end up causing a negligible, almost didn't spell that correctly, a negligible change in the demand. Okay, well, what if the cost of the book is $12.50? Well, let's compute the elasticity of demand if it's $12.50. So let's put $12.50 in here for the P's. And 600 minus 2 times a 12.50 squared. And again, I use my calculator here, and I'm going to round this. I get 2.7139. You know, the thing is, that's greater than 1. And when our elasticity is greater than 1, that tells us that at a price of $12.50, it's elastic. And if it's elastic, that means that a small change in price causes a significant change in demand. All right, so we get our elasticity of demand function, then we can evaluate it at any price and determine if at that price it's inelastic or elastic. So let's head back to the slides, because I think next we're going to decide, should we raise prices or lower prices once we know the elasticity of demand. So let's take a quick trip back to the slides. All right, folks, we just found that in that example that when the price of a book was $8, the demand was inelastic, whereas when the price was $12.50, the demand was elastic. So that what that really means is that when the book was $8, the price could have been raised and it would bring in more revenue. However, when the book was $12.50, the price could have been lowered to bring in more revenue. So what this tells us is that if the point elasticity is equal to 1, remember that's unitary, revenue would have been at a maximum. And this chart kind of summarizes some stuff for us, that if the demand is elastic, we know that means that the elasticity is greater than 1. R prime of P would be negative, the revenue's decreasing. If the demand is inelastic, we know that means that elasticity was less than 1. R prime of P is positive, the revenue is increasing. And if the demand is unitary, and we know that means E prime, or E of P is equal to 1, then R prime of P is 0. The revenue is at a maximum. Now I'm going to summarize everything here to crystallize it down to its most basic, really important form. So if your demand is elastic, prices should be lowered to increase revenue. If the demand is inelastic, prices should be raised to increase revenue. And if your demand is unitary, then the revenue, it's already at a maximum. Leave the price alone. It should not be changed. And here's one figure to kind of summarize it. There's the elasticity curve. Notice when EFP is 1, you're at a maximum. If EFP is less than 1, it's inelastic, so increase price to try to get to maximum revenue. Whereas if EFP is greater than 1, you're elastic. You want to decrease price to try to maximize revenue. So in this example, we are going to, write all the words down. Someone's making a keyboard, selling it $525. We know the demand function for the keyboards is given by DFP equals 2,000 square root 900 minus P. P is the price of a keyboard, and DFP is the demand. So we are going to determine E of 525. We are going to determine the elasticity of demand at the current price of $525, and that will tell us whether or not middle C should raise or lower the price to increase revenue. And then in part B, we're going to take the elasticity of demand, set it equal to 1, and solve for P to determine at what price the revenue would be the greatest. It would be maximized. So make sure you have this all written down because I'm heading off to the chalkboard to work through it. Hey folks, in this example, someone was making keyboards, they're famous keyboards, and they sell the PianoSoft 88 for $525. That's the demand function. P is the price of a keyboard and DFP is the demand for the keyboard. So in part A, we're going to evaluate elasticity of demand at $525. So at the current price of $525, we're going to determine if at that price demand is elastic or inelastic. And then that tells us if we should raise or lower the price. Then in part B, we're going to set the elasticity of demand function equal to 1, and we're going to solve for P. That will tell us at what price the revenue is maximized, at what price the revenue is the greatest. So let's get started here on part A. Remember, E of P is negative P times D prime of P all over D of P. So that's negative P times, okay, now notice folks, I went ahead and rewrote the demand function. I rewrote the square root of 900 minus P as the quantity 900 minus P raised to the 1/2 power. That's to help me get this derivative. So when I do the derivative there, let's see, the 1/2 comes out front, so that gives me a 1,000. 900 minus P to the negative 1/2 times, now I have to remember the chain rule. So I have to do the derivative of the inside. And the derivative of the inside is, well, that's just negative 1. Well, that's kind of nice. And that's all over DFP, which is 2,900 minus P to the 1/2. Now I'm gonna clean this up a little bit. First, negative P times negative 1, that's a positive P. 1,000 over 2,000. Well, that would cancel out with the 2,000 and leave me with a 2. So I'm not going to do any more simplifying. This gives me a positive P, 900 minus P to the negative 1/2 over 2 times 900 minus P to the positive 1/2. You know what? One more step of simplifying. I could take the 900 minus P to the negative 1/2. I could get a positive exponent by dropping that to the denominator. And then in the denominator, I'd have a 900 minus P to the 1/2 times 900 minus P to the 1/2. Well, you know, an old rule of exponents, you add those exponents because the bases are the same. And that simplifies to P over, don't forget the 2, times 900 minus P. No radicals are involved, no rational exponents. So it was kind of nice for me to simplify this. So next, we can evaluate at 525. So I get 525 over 2 times 900 minus 525. And let's see, if I use my calculator here, I end up getting 0.7. Notice 0.7 is a number that's between 0 and 1. That means this is, it's inelastic. Because it's inelastic, we should go ahead and raise the price. And in part B, now we're going to determine the price that will maximize the revenue. So now we know we're going to raise the price. So in part B, it says take E of P and set it equal to 1. Alright, so here's my E of P. Notice it's very nice that I have it completely simplified. Makes work a lot easier. So E of P is P over 2 times 900 minus P. Okay, so I set that equal to 1. And now I'm going to solve it for P. So I would start off by multiplying both sides of that equation by 2 times the quantity 900 minus P. So I get P equals 2 times 900 minus P. Distribute the 2. 1800 minus 2P. Add 2P to both sides. Divide by 3. And we found the price. That's what the price should be for the PianoSoft 88 keyboard. Should be $600. That will maximize the revenue. So folks, that's all there is here to the elasticity of demand. So you're good to go in this section. So at this time, I'm going to ask you to do all the exercises that were assigned in section 5.6. And thanks for watching.